Okay, so now we have the redox question, and it's asking us about a reaction between these two things. And the first thing in part A is that it asks us for the systematic name of HNO2. So remember that compounds that look like that, HNO2, HNO3, they're acids. Okay, so don't call it hydrogen nitrate or whatever any more than you'd call sulfuric acid hydrogen sulfate. It's nitric acid, except that it's not the normal nitric acid, obviously, because it's HNO2 rather than HNO3. So it's going to be nitric something acid. And what you have to do is to work out the oxidation states in order to work out what goes in the bracket there. So if we follow the normal rules, hydrogen in compounds is +1, oxygen in compounds -2. So 2 lots of -2 is -4, +1 is -3. So to make it add up to 0 overall, the nitrogen must be +3. And of course that's the one that we report. The hydrogen-oxygen oxidation states, you don't report them because they stay the same. It's the nitrogen that's variable, so that's the one we put in there. So it's called nitric 3 acid. So then we have to construct half equations for these, and if you've learnt the recipe, that's very straightforward. You've got to go through it carefully, but there's no kind of uncertainty that it'll work out. So for this one, you balance the elements that aren't hydrogen and oxygen. Well, they're already balanced, the nitrogens. Then you balance the oxygens by putting waters in, and you can see 3 on this side, 2 on this side, so we need an extra water on that side. Now the oxygens balance, but the hydrogens don't, so that's what we do next, because we've got 1, 2, 3 hydrogens on the left, only 1 on the right, so we need 2H+. And finally we balance the charges by putting electrons in, and you can see we've got 2+ on the right, 0 on the left, so it's 2 positive on the right, therefore the electrons need to go on that side. Okay, so you put the 2 electrons in there. If you find you tend to make mistakes, just double check and think, right, do the charges now add up to the same thing on both sides? If they don't, it means you put the electrons on the wrong side. So don't just ignore it, just have a go, move them around till the charges do balance on both sides. But you can see that now works. Follow the same recipe here, the ions already balance, but we need 4 waters on this side to balance up the oxygens with the 4 there. That gives us 8 hydrogens on the right, so we need 8H+ to balance those on the left. If we look at the charges now, we've got 8+ and 2- is 6+ on the left, but only 3+ on the right, so it's 2 positive on the left this time, so the electrons need to go on that side. To go from 6+ to 3+, we need 3 electrons in there. So those are your 2 half equations. Because the question asked for the half equations and not just the overall equation, you need to make sure those remain visible, even though you're now going to go on and multiply them up and stuff. Sometimes people get into trouble because they start crossing things out and all this kind of thing, and then of course they don't get the marks for the half equation. So you've got to be slightly careful. But you can see what we've got to do is to multiply this top one by 3 so that it has 6 electrons on the right, multiply the bottom one by 2 so that it has 6 electrons on the left, and then we'll get the correct overall equation. So in other words, we're going to get 3HNO2 plus 3H2O goes to 3HNO3 plus 6H plus 6 electrons. From the top one and doubling the bottom one, we get 2 FeO4 2- plus 16H plus 6 electrons goes to 2 Fe3 plus and 8 waters. Now we can add all of that lot up together, and we get 3HNO2 and 3H2O and 2 FeO4 2- and 16H plus. We won't put the electrons in because we know they're going to cancel, and that goes to 3HNO3 plus 6H plus 2Fe3 plus plus HH2O. Once you've added them up like that, there are then two important things you always must do. The first is to check if anything needs balancing. What's the word I'm looking for? Cancelling, if you've got anything that occurs on both sides. And you can see you have, because you've got 3 waters there, 8 waters there. You can't ever have the same stuff on both sides. So you're going to cancel out those 3 waters, which means that's going to go down to a 5. And you're going to do the same with H+. You've got 16 on the left, 6 of them are still there on the right, so again we cancel out 6 from each side, so that term disappears and that goes down to 10. So you can then just rewrite that as your final answer: 3HNO2 plus 2 ferrates plus 10H plus is your new left hand side, goes to 3HNO3 plus 2 Fe3 plus 5 waters. And the final thing to do, in an ideal world you'd check all the balancing, but that's going to take quite a long time. But what you can do is just a quick check to make sure the charge is balanced, because most mistakes that you make will get picked up because it'll mess up the charge balancing. So we've got 10 plus and 2 2s are 4 minus, so 6 plus altogether on the left, 2 3s are 6 plus on the right, so that looks correct.